Good evening, everyone, and welcome to the second video in the Deep Reinforcement Learning Portfolio Optimization video series. In this one, we're going to be going through the signal or the data preparation. The last video we had, and if you haven't, if you're not familiar with it, I would recommend that you go back into the repo. If you go underneath the wiki and you get to AWS execution, because this is where we'll be doing it. Here there's a pointer to the videos in which it shows you how to start up an instance. I'll just pause that right now. Shows you how to start the instance up on AWS and get SageMaker running. So I'm going to assume that you can already do that. And at the end of the last video, there was a new notebook instance created in SageMaker. So I'm going to assume that you've done that. If you've done it and it's been shut down, remember to click the button and go up to Actions, and you can say Start. I've already got one started up here now, so I'm just going to open it up. Open it in Jupyter. Okay, it has a little more than we had last time. And for this one, as I mentioned, we're going to do the data preparation. I'm going to come back to that interface in just a second to kind of walk through some of the files that are there. But I just want to show you the notebook first. The first thing that you'll have to do is when you run this, is this first time you've had this particular instance up and running, you are going to have to install an additional package in here. So just uncomment that, and so it has the exclamation mark. That just means it's a command line for pip to install this Alpha Vantage. And Alpha Vantage is actually how we're going to get all of the stock data. And to do that, you do need to claim your API key. So if you try to use the key that's in there right now, it'll cause all kinds of problems. So please go grab your own key. Just follow these types of these instructions. It's super simple. You just get yourself a little key here, and then you'll be able to go in and grab all the information. I would also recommend maybe coming in through and looking through the documentation. There's all kinds of different data you can have to help build your models, different inputs that you could try to use. It's a pretty good resource. So once you do that, and I'm just going to go in and just say cell run all. It'll just go through right now and run all of the cells, starting from the top. And you can see here it went in and said that it already satisfied it, so it didn't have to install it for me. If you were going to run it for the first time, you probably would get some different messages here where it's downloading the information. One of the other things I kind of put in as I've just turned it here into raw so it didn't run, but you may want to kind of play around with it a bit if you're interested. Just some of the other packages in that Alpha Vantage. This one, for instance, has a bunch of sector data. So for all the S&P, you can go in and grab maybe some sector information. A lot of very interesting things here. I can just turn it back into raw, and that way it doesn't run. So we just walked through the notebook. One of the first things it does is it opens up a settings file. It's a little YAML file. If I go back into this interface here, you can see that there was a YAML file in the repo. You can click on it and open it up, and this is where it says which stocks to download, so these tickers. So if you want to go and add some others, you can certainly go in and add away, and it will download those. In addition to, I just basically have two stocks in this demonstration, and the other one that I have in here, the SPY, that's actually just an S&P 500 ETF that's replicating the index. So I'm kind of using that as the market for these particular stocks. And it also shows where we want to have our data start and end for training. And then actually the training itself, or this is all of the data, and then when the training ends and we have a testing. So you can see now we have 2018, 2020, 2 years, or 2018 and 2019 will be our testing years, and the training kind of ends in 2017. And then we also have prediction days. I'll go through this in a little more detail, but effectively when we go in the next video, this is where it shows how far in the future, and these are trading days. So 1 day, 5 days, effectively a week, 21 days, which is effectively a month, and then some different parameters. But this is kind of how you can go in. You can edit it, save it, all that sort of thing. It's a nice little interface. I'm not going to save my changes right now, but it just reads that file. Then it comes in. Again, this is the API key, so please don't use this API key. Go grab your own API key and put it in here. There's actually a lockout, so if you use someone else's key, there's a chance you'll both get busted for 5 API requests a minute and 500 requests a day, which is just kind of rude. It goes in, it actually looks to see if you've already downloaded the stock data. So it's going to look in to see if this file is sitting in the directory. And if we go in again, there's this stock data file. So if you don't want to download it, you can, or if you don't want to re-download the information, you can just click on it here and you can just download it to your PC. And that way you can upload it later and reuse it. And if you want to upload, it's just the upload button here. Very nice, obviously a very simple type of interface. So if you want to just upload the stock data instead of going and getting new stuff, you certainly can. It just comes back through, starts to do some plots, kind of shows the data that we have now. And it's, again, from that 2018 to 2020 timeframe and the 3 different stocks that we had. One of the things that starts to go now is look, see if there's any sort of data. You see if there's any dropouts. If there are any sort of dropouts, one of the things it'll start to do is do a fill. So it'll do a linear interpolation between the points to kind of make sure there's no data dropout. Sometimes when you do the plot, you'll see a little drop down here, so we want to get rid of all that, a little bit of data cleanup. And then when we're going to get in, we're going to look at the log return. So when we do our prediction, we won't be doing our prediction directly on the log or the stock prices. And the main reason to that is whenever you're doing a machine learning model, you really want to have your data normalized, usually, between -1 to 1, 0 to 1, something along those lines. But if your stock, is continuing to grow, then it's certainly, it's much harder to train your model. So if you first convert it all into returns, we're doing, of course, log returns here, but even in the regular returns, then all of a sudden your data looks much nicer. It's naturally normalized. The other big thing we're going to do is we're going to divide our prediction. So instead of trying to predict what the particular return is going to be, it's going to say whether I think it's going to be basically 5 different ratings on the returns. You'll be, very bad, bad, neutral, good, and very good. And what we're going to do is we're going to bin this, and I'll just show it a little further. It's with some pictures makes it a little more straightforward. But effectively in the neutral, which is around 0, we're going to put 20%. So we're going to set these bounds, and this is what this is doing here. It's doing a little tiny optimization, this minimization here, where it's setting the bounds on the neutral boundary so that 20% of those returns are in that bound. And then above that, it'll divide it in half. And you'll see it a little bit further. But then, of course, it has, we see it goes down through. It's in the set the bounds for 3 different prediction timelines. I guess one of the 1 day, 5 day, and 12 days. First, kind of pick the boundaries around neutral. So you have 20%, and then above it and below it, with the second boundary, you can see this is a plus or minus 0.2%, and then the minus 0.9% and a plus 9%. And these don't have to be equal. This is just at 1 day, it's pretty normal. But here you can see it doesn't have to be exactly the same on either side. And if we can come down a little further, you can see this in a histogram. So this is for the 1 day, and I apologize for this error that comes through on the AWS. But here if we can see the returns, a little histogram. We've picked the boundary, and that's these 2 boundaries right here, the plus or minus. It was 0.2, I believe. Yeah, 0.2. And that has 20% of it. And then this boundary was picked so that half of the above and half there. And that's kind of how it's binning it. And then it's going to classify it. So then you have all the returns here. It's going to be very bad, bad, neutral, good, and very good boundaries in for those 3 different time horizons. This is just some little plotting that we have to kind of make it a little more clear, where you can see now, and I apologize, it's not terribly, very, very small on this interface, but you can kind of see here we have 0, and then there's 2 color bounds. There's a gray right around 0. Then there is a 2-tone green on either side. And if we go into the price history, let's see if we can go down to the other ones a little better. Now, this one spreads apart a little more. And this is one of the big things is your DT. So the first one, this was just a day, and so it was very small returns. Of course, when you go into the 5 days, now the returns start to get a little bigger. You see a little bit more spread. And really what we're trying to do is predict on our next step was the following day, 5 days, 21 days, do we expect to see a very bad return or very good, neutral? And that will then allow us to build our trading portfolio. And this 5 days, again, 21 days, it's starting to get a little bit more crisp, right? And these kind of peaks. And so these are really the peaks that we're trying to get in there and see if we can predict and trade off of them. And you can just shows the return, the prices themselves. Obviously, the red is where there's been some big drops. That's just a little, I usually do my plots afterwards. It's more of a sanity check on my own to make sure that the processing has been done right. By eye, you can usually check pretty quickly. So now that we have that, I want to go and just store it. So on the next notebook that we have, when we try to do our prediction, we can just reuse this data. So we don't have to do that connection and re-downloading the data as we're working. And one of the big things it's doing is kind of just making a nice, clean data set for us. So again, it's got now all of the returns for the 3 different time horizons. That's why there's kind of 3 different time horizons here. And then it has the classification. So if you're looking, at a certain amount of time, so at time, 53rd day, you're going to say, based on all that previous thing in the past, what's the prediction for 1 day ahead, 5 days ahead, and 21 days ahead? Is it good, bad, or ugly? And that's the different classifications. And it has to do a little bit of cutting on either end, because of course, if you're looking for a 21 day prediction, you can't have data right up to the end because you have to back off from that last day by 21 days. Certain things like that to kind of make sure that you have a full data set. The other thing it's doing is normalizing the input. So again, when you're doing the machine learning, you usually want to try to normalize your input. So here we're getting the mean and standard deviation and just normalizing those inputs. So we're going to train actually on the normalized log returns, which is just simply found the mean and standard deviation, subtract the mean, divide by the standard deviation, gives you a very nice clean data set. And then we just drop it as a pickle file here. The stats, of course, are required for if we get some new data. We want to normalize with this same set of normalization. So you wouldn't normalize with, if you got some new data coming to you, you would normalize by the mean and standard deviation of the new data. You'll normalize by these particular means and standard deviations. And if we go back into this particular file here, you can see this is the training data stored. So again, if you wanted to download it, upload it, you can certainly do that sort of thing here instead of having to run this notebook, but it is super fast, so it certainly doesn't hurt. The other thing I wanted to kind of show very quickly was you can go in and edit the files there. The other thing that's kind of nice is there is a terminal. So for those of us that like playing in terminals, right, you can see here this is a Linux terminal that you have. So if we wanted to go in to SageMaker here, we can see this is the Git repository that we have downloaded and all our files there. So if you'd rather work in this type of interface, it's there for you as well. Or you can kind of go back and do the click and the GUI interface if you wish. So that's basically it for this. I try to keep these videos fairly short. We're at 13 minutes now, so I'm going to cut it down. But again, this was a little workbook to go and grab the data from the internet, clean it up, make it nice and pretty. So then when we go in and we start building our model, we can kind of just reuse this data set. The first step will be in the next notebook. We'll be loading this particular data set here. And then the only other thing I kind of want to show is, remember, always when you're going in here, you'll probably want to, when you're finished, make sure that you either shut it down so it's not running, even though this instance actually is very small build, but it's just general sort of good housekeeping to stop your instances once you're finished using them. And shortly I will come back with another video where we will come in, do the same thing. This time we'll look at the signal processing itself. Thank you, and talk to you soon.